Okay, some new software. So question number one, which choice could be modeled by a linear function? So let's remember a linear function is where we add the same amount each time. Like we're adding, like it says right here, we're adding 4, we're adding 4, we're adding 4. Over here, we're multiplying by 3. So anytime you're increasing by, so earning 4% interest, that's increasing, that's multiplying by your, because you're multiplying by 4%. The second one, you're adding 4 cents per minute. So that looks like the winner. Let's just double check the other ones. Reaches 2/3, so you're multiplying by 2/3, 30%. Anytime it's a percent, it's going to be your exponential equation. Anytime you're multiplying by a fraction, it's going to be your exponential. Remember, your linear is where you're adding a set amount, adding 4 cents per minute every time. All right, next question. The expression m minus 3 squared is equivalent. Well, remember, m minus 3 squared is n minus 3 times m minus 3. So you got a FOIL. So you get m squared minus 3m minus 3m. Negative 3 times negative 3 is plus 9. You combine your like terms, and you get m squared minus 6m plus 9. All right, the next one, an example of a 6th-degree polynomial. So with a leading coefficient of 7 and a constant term of 4. So the degrees, what are degrees, is whatever your highest power is. So you can see an example here, it's 3. So we're looking at something with a highest power of 6. So that rules out number 1 because that's highest power is 7. Number 3 is ruled out, its highest power is 4. So we're choosing basically between 2 and 4. Now, the leading coefficient of this one, number 4, would be 4. So that doesn't work because we want a leading coefficient of 7. So number 2 has a leading coefficient of 7 and a constant, which is the constant is your last term of 4. So that's that one. The function is shown below, g of x. What is g is 30? Well, you just plug in 30 for x, and you get 19.6. 19.6, and then 1.4 times our x, which is 30. You do the math, you get 71.8. All right, the table below shows the weights of 8 different types of bear. Notice this one's kind of an outlier, right? The polar bear. If the weight of the polar bear is removed, which statement is true? So an outlier is where we have a number that's much larger or much smaller than the rest of the data center. So as soon as we take that outlier out, the mean is going to change significantly, right? And in this case, the mean is going to decrease because we're taking out a huge number. The median is going to stay relatively the same because remember, the median is the middle value. So the right answer here is A. All right, these box plot diagrams are, remember, this whole thing is our range from our minimum to max. Our first line here is our first quartile, our middle line is our median, and our line here is our third quartile. Between the first and third quartile is our interquartile range. So what is the range? Well, we go from 67 to 76, so 76 minus 67, our range is 9. All right, which is not a function. So remember, a function, every x has to map to one and only one y. So this maps to one y, this maps to one y. On a graph, you can use your vertical line test. This is a function, which is fine. This one is the right answer because it's not a function, because notice 2 maps to both A and B, and you can't have an x mapping to 2 different y's. All right, what is the distance between the y-intercept of the function and the y-intercept of the function presented below? Okay, so let's find the y-intercept of g of x first. So we're going to do that. We've got to find the slope. So remember, we changed the slope by the change in y over the change in x. So that's 15 minus 3. We get a slope of -4. Step 2, we use the point slope, right, to determine our y-intercept. So our y-intercept is -5. The function 2x. So the y-intercept of this one is 3, because when x is 0, right? So 0, to find the y-intercept, that's when x is equal to 0. So you've got this first line is the y-intercept's at 3. Second function, the y-intercept's at -5. So the difference between those two is a distance of 8. Okay, next one. The function f is shown in the table below. Which type of function is this? Well, let's see. We added 2 here, and we added 6 here. We added, 16 here, so it's not linear. We know it's exponential. And then is it growing? Is it getting bigger? Yes, it is. It's not decreasing, which would be decay. So it's an exponential growth function. Graph below function is shown on the graph. Which function best represents this graph? Well, a couple ways we could do this. We know we got a y-intercept at 4 and an x-intercept of 6. So we know that the point 0,4 better work in our equation, right? Because that's there. And we know when x is 6, y is 0, so that better work in our function. So one way we could do this is we could plug each one of these. Okay, this is our x, and this is our y, right? So let's see in this first one, if we plug 0 in, we do get 4, so the first one works. When we plug 6 in for x, we get 36. We don't get 0 for y, so that one can't be right. Let's see this second one. When we plug the first point 0 in, we don't get 4 for y, because we get -2/3. So let's see this next one. When we plug 0 in for x, we don't get 6, or we don't get 4. Let's see this last one, better work. When we plug the 0 in for x, we get a y of 4. When we plug the 6 in for x, 6 times a -2/3 is a -4. We get a y of 4. So that one works. Okay. Let's see what else. The values of the tables represent a linear function for what is the rate of change. So anytime you see rate of change, that's the same as the slope. Right? Rate of change is slope. So they're just asking for the slope. So we just count our change in y over change in x. And that turns out to be a positive 2 if you do the math. So -17 minus a -92. -1 minus a -8.5, do the math, and you get 10. Okay, then throws the ball into the air and lets it fall to the ground. The height of the ball is modeled by this equation with h measured in feet and t in time. Number 3, so they're figuring out what this is. Well, if you think of it, when t is 0, this is 0. When and this second term is 0. So the height of the ball at 0 seconds is 3. So it's the height at which t of 0 is when you throw the ball. So the height from which the ball is thrown. Okay, given g of x, this, which statement is true? Well, it's asking us what the zeros are. Remember, zeros is where our y is equal to 0, so it crosses the x-intercept. So we've got so the first thing we'd want to do is factor this thing, factor this guy right here. So we got to come up with things that multiply to 16 and add to a -6. Well, that's -8 and 2. All right, so x minus 8 times x plus 2 is this function factored. So we got x equals 8 and x equals -2, which is this guy right here. Okay. Which ordered pair is a solution set of 8x plus 16y greater than 32? The easiest way to do this one is just plug in these answers, right? So let's see if 0 and 0, 2 works. No, you put that in, it doesn't work. Negative 3 and 5, yep. Plug that in for x and y, and it is greater than 32. The other ones are not greater than 32. When you just simply, all I've done is plug this in there, plug this in there for x and y, plug this in there for x and y, and plug this in there, and I'm plugging them all into this equation, right? And see if they work. What is the equation in slope-intercept form of the line that passes through these 2 points? Well, if they give us 2 points, the first thing we got to do is calculate the slope. And then once we have the slope, and we have the slope in 1 point, we use our point-slope formula. So we calculate the slope, remember change in y over change in x, so we get a slope of 9/13. And then once we have that 9/13, we pick 1 point. Doesn't matter which one, I picked the first one for my y and my x, and I solve it, and I get y equals 9/13x plus 7. Okay, the graph of the linear function passes through the points, the 2 points. So it's the same question essentially, except they've given it to us in a graph rather than a format. So we calculated the slope. Once we had the slope, we put it in our point slope. We have the slope in 1 point. We put it into our equation and solved it. A ball is placed in a machine that throws it up in the air. The table represents some of the points in the graph that models the ball's distance from the ground with respect to the time since the ball hits the ground. What is the range? So the range is our y value. So our y here is distance, right? So we go, our minimum is 0 and our maximum looks like 7.6. So our range goes from, all real numbers, we want them greater than 0, less than or equal to 7.6. So read it carefully. I almost went for this one, right? Less than, we want it greater than 0 and less than 7.6. Okay, which graph represents a solution set of these two inequalities? Remember, if it's less than or greater than, it's a dotted line. If it's less than or greater than equal to, it's a solid line. So if there's an equal sign, it's a solid line. If it's just greater than or less than, it's a dotted line. So let's pick some points and see if they work, because we know 0, 0 is 1 point. That's an easy one to try, because notice it's shaded in some instances and not shaded in other instances. So we put the 0, 0 into the first equation. Is 0 less than 1? Yeah, that's true. Is 0 minus 0 less than 2? Yeah, that's true. So 0, 0 has to be shaded, so we can immediately X out C and B, right? So now we're down to A and D. And notice this one has a solid line here, and this one has a dotted line here. So the point 0, 1, if we put that in there, right, we'll figure out what's going on. Well, 0, 1 doesn't work in this one, right, because 1 is not less than 1. So we know the point 0, 1 must be a dotted line, because we don't want to include that. So that makes our answer A. The graph of the quadrant on the graph below. Which function best represents the graph? Well, again, note that we have zeros at -4 and at 4. And note that we have a y-intercept at 0 and 8. So we can test some of these points, right? All these points have to be on the line. When x is 4, y is 0. When x is -4, y is 0. When x is 0, y is 8. All those have to work into these functions. So just plug them in. Right off the bat, 4 doesn't work here. It works, but doesn't work with 0, 8. The only one that works with all of them is H. Okay, what is the equation in standard form of the line that passes through the point is parallel to this? Well, you have to remember two parallel lines have the same slope. So we figure out the slope of this line, right, which is what did we figure out? Negative 8/3, right? And then we put it into our point slope formula. Now the only thing that was tricky about this problem is it gives us this answer, but that's not there. They put them all back into standard form, so you have to write it back into standard form to figure out which one's right. Part of a linear function is graphed on the grid. What is the range and the domain? So remember, the range is our y values and the domain is our x values. Also remember, a solid circle includes the number 2. Open circle would be everything but not including the number 4. So here we have both solid circles. So we're going, our x values are going from -7 to 6. And our range, our y values are going from -4 to 5. So there's our answer. Okay, which graph shows the solution of the given inequality? So again, we have the two inequalities. The easiest way, again, I think, is to put our inequalities here and see which ones work. So once again, the point 0, 0 is in some of these, but not in other ones, so not eliminate. So 0, 0 doesn't work, so it can't be shaded. So immediately, anything where 0, 0 is shaded, we can X out. So we're down to answer 1 or 2. Now, notice again, we got, right off the bat, we could kind of say it's got to be number 2, right? Because we got to have a dotted line for this one and a solid line for this one, and number 1 gives us 2 solid lines. So must be answer number 2, or you could have tested the point 2, 0 to see if it's there. Alright, Keith determines that the zeros of the function must be -6 and 5. What's the function? Well, I gotta have it, to get the -6, I gotta have x plus 6. And to get the 5, I gotta have x minus 5. Because remember, you're gonna set each one of these equal to 0 to solve for x. Okay, the table below shows the average diameter of pupil's eye as he goes over. What is the average rate of change? So again, rate of change, as soon as you see rate of change, think of slope. So you just calculate the slope. Change in y over change in x, and then simplify. Alright, keep track of his profits. He found that his profits only declined between 10 and 40 tickets. So this is just reading the chart. So between 10 and 40 tickets, this one's flat, it's not declining. 10 and 40 tickets, this is the only one where it's all declining. 10 and 40 tickets, it's increasing. Here, between 10 and 40, it's going up and down. So our answer is the zeros of the function. Alright, they want us to factor this guy so we can get the zeros. And so we need something, factors of -24 that add to -2, so that's -6 and a positive 4. So, and we set each one of these equal to 0, so x equals 6 and x equals -4. Alright, which inequality best represented on the graph? Again, an easy way to do this is to say, well, we know our y-intercept is 0, 7, so that point, well, first off, it's a dotted line, so we can get rid of these equal ones, right? And now we can see if it's equal to these 2 points, our x-intercept and our y-intercept. So G, it's yes and no, it doesn't work, the 4, 0 doesn't work, and J, they both work. The contractor's total earnings from a job includes a fixed amount, base number of hours, the value of the linear representation. What is the rate of change? Well, once again, rate of change is slope. So this is simply take our change in y divided by our change in x, and we just calculate it. Which statement best represents? All right. So this is, notice here, every y value is 2.5. So we got y is 2.5, and it's parallel to the x-axis, because here's my x-axis, right? And I'm parallel to it. And in every case, y for every x, y equals 2.5. Which expression is equivalent to, okay, anytime, another tip, anytime you see two terms, there's one term, there's two terms, check to see if you got a difference of perfect squares. Well, this is a perfect square, 3n, right? My writing's kind of bad. And this is a perfect square, 25 perfect square is 5, right? So we got 3n minus 5, 3n plus 5. All right, the linear function t has a x-intercept of -1 and a y-intercept of 5. Okay, so it's got intercept. There's our y-intercept of 5, but our x-intercept is 1 on this one. There's our y-intercept of 5 and our x-intercept of -1. So there we go. Which graph represents the solution of y less than or equal? So we know it's a solid line, right? Because it's less than or equal to, so we can immediately get rid of these two guys. Now we can just test a point, because 0, 0 is on this one, 0, 0 is not on this one. So if 0, 0 works, it's got to be this guy. So 0, 0 works, so it's that guy. All right, the graph shows the height and feet of the object approach the ground and launch the ground. Notice when t was 0, it had a height of 0. It goes up to a maximum of 64 feet. So a couple things we could do. We could test the point 264 and see if it works. And plug them into the equations, right? We know this guy's out, right? Because when t is 0, our height is 0. And these two, when t is 0, the height is -256. All right, so if you plug the point 2 in 264, you'll find that there's your answer. What value then makes, okay, this is just simply, the easiest thing to me would be just plug 3 in for n, -9 in for n, 0, and see which one works. Another box whisper, what's the medium? Remember the medium's the middle one, so the middle one would be 75. Remember the first quartile, third quartile, this middle one is your median. So 75 would be our answer. 4 different, what is the greatest range? Remember range is minimum to maximum. So these all have the same minimum value. This one has the largest maximum, so this one would have the largest range. Okay, scatter Okay, so it looks like we got us going like this. Looks like a positive correlation, right? So there's a positive correlation between popcorn sales and soda sales. Popcorn's positive correlation means as it goes up, the other one goes up. So the popcorn sales goes up, soda sales go up. No correlation would be they're not related to each other. Which expression is equivalent to this and this? Okay, they want us to factor this guy. So we got to come up with factors that multiply to -60 and add to -17. You can see that's right there, right? You can just look at them and FOIL them if you need to, but this is going to give us, wait a minute. Sorry about that. This one's going to give it to us, right? Because we need a -17. Yep. So x times x is x squared. There's our plus 3x minus 20x. Minus 20x plus 3x gives us the -17x. -20 times 3 gives us our -61. All right, baby rhinos, once again, you're going to find the slope from your starting point, and then you're going to extract it out for 5 years, and you're going to get about the 6%. The expression is equivalent. Okay, we just factored this one, didn't we? Well, okay, you got to get the multiples of 24 that add to 10, or add to -10. So plus 24 minus 2, that's going to give us a -24. -6 times a negative 4 gives us a positive 24. A negative 6 plus a negative 4 gives us a negative 10. There we go. Alright, let f be the function is defined by the domain of 2 to 6. Okay, so if I find the range, I just plug in a domain from 2 to 6. What's f of 2? What's f of 6? So my range is 0 to 8. Width of a rectangle is 4 less than the length. If L represents the length, what equation would be used to find the width? Well, let's talk about some words and how to take them into expressions. The width of a rectangle. So the first thing I'm going to do is write W, because that's what I'm trying to find. Is. So is another way of saying equals. 4 less. I put that at the end, right? So let's stick that out at the end. Half the length. 1/2 the length. So my equation is W, 1/2 the length, minus 4. Which expression is equivalent to this? Well, okay, all we have to do is FOIL and we get it all done. Cost of varying a commercial number of times based on this module, which statement is true? Well, okay, let's see. What this is saying is for each one it costs $110 and a startup cost of $900. So it's the commercial costs are $900 to produce, so no matter how many I make, I have to pay $900 and $110 each. Alright, the graph row shows the jogger between 9 and 12 minutes interval, so that's right here. Notice it's flat, but it's flat. They're running at a rate of 6 miles per hour. So they're not standing still, they're running at 6 miles per hour. Their speed isn't increasing, their speed isn't decreasing. They're jogging at a constant rate of 6 miles per hour. Okay, 2 customers went to the post office to buy postcards and envelopes. Okay, let's let E equal the cost of one envelope, right? Because that's what the question is. What is the cost in dollars of the large envelope? And let's let P the cost of one postcard. So we know from the first equation 14P plus 5E equals 12. From the second equation we know this. Now this is a little tricky. I multiplied the first function both sides by a negative 3. So that then when I compared it to the second function, I could just subtract them, and I solved for P. Once I knew P was 35 cents, I substituted in the first equation, solved for the envelopes, and it's $1.41. Which statement about GFF is true? Again, think difference per C2 terms, think difference of perfect squares, right? So 756, you got a calculator, that's a perfect square of 24. So it's x plus 24, x minus 24. Given this, what is the value of f16? Well, just plug 16 in for x and solve it. What is the solution of this and this? Well, the first thing I'm going to do is square this. And remember, x plus 7 squared is x plus 7 times x plus 7. FOIL this, set it equal to 0, factor it, and then solve for it. Which graph that has only one 0? Remember, a 0 is when y is equal to 0, or it crosses the x-axis. Well, this one has 2 zeros, right? Because it crosses the x-axis twice. This one also has 2 zeros. This one has no zeros. And this is the one that has 1 0. And we're done.